Hello guys, hope all of you are doing great. In this part of the video, we'll be seeing how we can write a procedure, an explicit procedure to print a number in 8086. So we have seen in our part 14 and 15 that how we can display a number on the screen, maybe positive or negative. But here we'll be learning explicitly how we can write a procedure that we can call again and again whenever we have to display a number. So let's see what is the requirement that, okay, say, suppose we want to display the number 595 on the screen. In that case, first we'll store the number in AX register and then we'll call one procedure, say for example, display N. So in that case, it should display as 595 on the screen. See here, displaying this number, which is there in AX, is done by or will be done by this particular procedure. And this is the procedure that we have to write. Say we assume that the procedure is written, that in that case, if we write something like this, we'll get this output. Say for example, first we store 595 in AX and then we call the procedure, we'll get 595. Then again, we change the value of AX to 603. In that case, again, after that, if we call display N, it will show us 603 on the screen. Okay, then let's begin today's part. Again, I'm starting from the basic skeleton of the 8086 program. So if you do not have this skeleton, so first thing, you pause the video and please type this code. And after that, you can start typing with me. Or if you're interested only in the code, in that case, you can skip towards the end of the video. There I'll be scrolling over this entire code slowly so that you can see the code and you can type the code directly. Okay, then. So our goal is we have to display the number on the screen, and we know that for that we are going to make use of repeated division operation. The logic and everything, as I said, I have already explained in part 14 and 15. So I'll be assuming that if people have, you know the concept there. Okay, so what we'll be doing is, okay, first thing is that one slight change I'll do here. Here I'll be doing 16-bit division, not 8-bit division. That will be the minor change here. I'll be coming to the point, or I'll be telling you the details when I reach that point. So the first thing is that we'll assume the number that we have to display is in AX register. So first, let's make this basic setup first. Move AX, comma, say for example, 509, say, okay, and then what we want to do is we want to call the procedure, say for example, display number or display N, and that's all. And say I want to store a different number and display number, a different number, and again I want to call display method. So let me write it one more time. I'm just making it same as more or less what I wrote here. Okay, so maybe 607 or something, and then display N. So in this case, if we fill in the blank like sort of program, like if we create this procedure now and we execute this program, we should get 509607 as our output. Okay, done. So we know what we have to do is now we have to fill this procedure. We have to write this procedure. So for that reason, let's say we have to start with the name of the procedure. So we know display N is the name of the procedure, followed by this assembler directive. The last instruction must be return instruction, and after that, this is the end of the procedure. Done. The basic skeleton of the procedure is ready. Inside this procedure, what we assume is AX is the number, okay. So you see here, like semicolon means it's a comment line, just for our reference. Done. Now what do we want to do? AX is the number that we want to display on the screen. So for that reason, first we'll be like separating the digit of AX by repeated division. So what I mean by this is, you see here, say this thing here. Say for example, AX is 509. So what we'll be doing is we'll be dividing AX by 10 again and again. See, if I divide AX by 10 for the first time, this 9 will be the digit, separated digit. Then next time if I divide, 0 will be the separated digit, and then last 5 will be the separated digit. So what we do is, as soon as we get the digit separated from the number, we'll push it into the stack. So that's how, see, if we divide the number again and again till we get 0 and push all the digits into the stack, at some point at the end of the division, the stack should look something like this. Just an overview. Okay, now let's see how do we achieve that thing. So for that reason, what we'll be doing is, we know our number is in AX, but again, before that, one more thing, we'll be assuming that we'll be doing this, DX colon AX. That is the combination of DX 16-bit and AX 16-bit. Total 32 bits, we'll be dividing it by a 16-bit number or a 16-bit register. Say, for example, this BX register. So if you do that, like a 32-bit by 16-bit operation, if you perform, then you should remember that the quotient will go to AX register and the remainder will go to DX register. Now see, if you want to perform 16-bit by 16-bit operation, in that case, you have to always assume that DX is 0. That is, you have always, before performing the division, you always have to set this DX value to 0. Understood? So main point here is that we'll be performing a 16-bit by 16-bit operation by setting DX to 0, and after division we will see for our result in AX and DX register. That is, if we are interested in seeing the quotient, then we'll be seeing it in AX, and if we are interested in the remainder, then we'll be seeing it in DX register. Having said so, now we are ready to write the code smoothly. So done. Now first, since we're doing 16-bit by 16-bit, let's reset this DX to 0. XOR DX DX. Okay, reset. I'll try to write the command, comment also, reset to 0. To 0. I might do some spelling mistake, don't worry about it. Reset to 0. Okay, done. And once it is done, we want to divide it by, see here, what are the things that I need here? I want to divide it by a 16-bit register, and the number by which we want to divide, that is fixed, that is 10. So let's take any 16-bit register, say for example BX, and there I store the number 10. Okay, because we want to divide it again and again by 10. Then after that, you call this division function, a div instruction, and div bx. So when we write div bx, it will basically, what it will do is, it will do this dx by bx. That is the combine, this 16 bits it will try to divide by bx. Okay, and after division, q will go to ax register, and the remainder will go to the x register. Okay, that's just for your hint. Done. Now we have divided the number by 10. Then now we are interested in the remainder part. So we know the remainder is in dx, and we want to push the remainder into the stack. So, but one more time, let me come back here. See, if I divide the number, say, did I write somewhere? Say here, if I divide this number by, say for example, you consider 10, then what is the remainder? The remainder is 9, the number 9. Okay, but what we actually push into the stack is not the number 9. We want to push into the stack the ASCII character 9. Okay, so for that reason, along with that remainder, we have to add actually the ASCII code of 0. So for that reason, I'll be writing it, add the remainder plus the ASCII code of 0. Okay, that is achieved in this way. It is just to convert remainder to ASCII code. Okay, just for your hint, why am I doing it like that? Then once it is done, then we are ready. We can push it into the stack, push this dx register into the stack. Done. And after that, how many times we do this push operation, we want to keep track of it. So for example, for that reason, I'll be using a counter. I can use cx, so I can increase cx register. But if I do increase cx, obviously, then we have to reset cx to 0, cx comma, or I can write directly x or cx comma cx. So cx is 0, and cx set to z or 0. Done. Okay, so cx was initially 0, so every time we do a push, then we'll be increasing cx. Done. And after that, we get the remainder, we convert it to a character ASCII code, and then we push it into the stack. Then whether we want to proceed further or not, that will be decided by the quotient. If the quotient is not 0, so for that, again, I'll be doing compare ax comma 0. That is, we are comparing, like checking actually, check if q is 0. If q is not 0, it means we still have something. You see here, in this case, 509 divided by 10. For the first time if I do, and if I consider the quotient will be 50. Next time if I do the operation, that is division by 10, quotient will be 5. And third time if I do the division, then quotient will be 0. And after that we don't have to continue because quotient becomes 0. So that is the thing that we are following here. So we are comparing ax comma 0, check if q is 0. If it is 0, that is jump on equal, we are done. We are sort of done creating the stack actually. So I'm writing here a label, say for example pop q. I'll be writing the details of the code below, but say we are done. We are now ready to pop the content of the queue and form the string. But if it is not the case, then I want to repeat this division operation. That is, I want to clear this dx, and that is I'm calling it, say for example, next div. So clear this dx. See, we don't have to clear cx every time because cx is the counter basically, but this dx, before performing the division, we are clearing dx. We are moving 10 to bx, and then we are dividing again whatever it is in dxax by 10, dxax by 10, and then based on the like whatever it is the remainder, we are pushing it into the stack. We are increasing cx, we're comparing whether the remainder is 0 or not. If it is not 0, then we are again going back to next division here. Okay, if it is not 0, we are going back to next division. So that is the process that will be repeated again and again and again. Clear? I think I wrote everything right here. So if you now do it repeatedly again and again, at some point of time this ax will become 0. That is an indication, okay, our stack is made, like we created the stack. Right, the next time is we have to pop the elements out of the stack, and we have to construct this intermediate string pointed by bx. Okay, so that's what is the next step. So we are now ready to write the code for this level pop q. So here what we'll be doing is how many times you have to perform this pop operation, whatever it is the value of cx, we don't need to worry about it. Then we directly can perform pop the content to a 16-bit register, because we know pop will always return us 16 bits. So 16-bit, and you store that 16-bit top of the queue in the X register. Okay, and once you do that, what it is that you are looking for actually, although we are removing 16-bit because we inserted this thing as 16-bit, but you see here this 16-bit means only these lower 8 bits are the character, these higher 8 bits are actually 0. Okay, so for that reason we can discard that higher 8 bits, and we can keep only the lower 8 bits there, and that is the character we are interested in. But the thing is, before like you start actually popping, first do the initial setup. That is, we want our bx register with the starting address of the string 1. And what is our string 1? Basically it contains a set of null characters, okay, or this dollar symbol, which you can like equivalent to null characters in C programming. Now the point is that what we are going to do is we are going to fill up to some portion, like say 5 digits, 4 digits number based on the number that we want to print. So some portion of the string will fill with some actual characters, and rest of them will remain this dollar. So the first dollar will always be considered as the end of that string. So we are not going to store dollar explicitly, since we have enough of them. Automatically we just have to, only thing which is left is now we just have to fill this these valid characters there. Rest of the thing will be automatically taken care of. Understood? I hope so. No? Okay, done. Now pop dx, we pop the element we are interested in. Now see, load the effective address. Bx is now pointed by this string 1. Not only that, because you see here what we'll be doing is we'll be storing, actually when I want to do that, we want to do something like this. We want to do bx plus whatever it is si. We want to store there the popped, the lower order 8 bits of the pop 16 bits, so which will be there in the L. Okay, so first time we'll want to store it in the 0th place. Bx plus si suppose 0, so bx plus 0 means this, bx plus 1 means this, bx plus 2 means this, like that. Okay, so for that reason what we want to do is we want to initialize this where am I doing it? Yes, here. Make the bx to point to string, and also you just clear si. Okay, so we have to reset SI. So SI will be used as index. SI will be the index. Okay, just for your hint. Done. Once it is done, pop the character and then store it. Move the character to this particular array, I mean this memory location. Actually, we want to write bx of si, which we'll write in 8086 as like bx plus si. Move this to this location. We want to move the character dl. That's all. And once it is done, we want to decrease the value of cx, but since the value is there in cx, we can make use of this instruction loop and pop next. Okay, so if we want to do that, so this pop next will come here. Okay, so pop the character, I mean pop the 16-bit, get the lower order 8-bit to this location, and then pop next. But before popping next, we also want to increase si so that it points to the next character next time. Got it? Okay, now pop next, and then done. Once everything is popped out, say cx is 3, in that case 3 times we'll be doing this pop operation. We'll be constructing the string. Only the string is constructed. The final step is we have to display the string. So we know if we want to display the string, we can do something like this. We have to store 09h in AH register, then we can call this interrupt service routine in 21h. What these two lines will do, these two lines will display the string which is pointed by the x register, right? Not by bx. It will display the string pointed by, it will display the string pointed by the x register. Okay, so it all automatically assumes that okay, there is a string, starting address of the string is there in the x, I have to print that string, something like this. But right now, dx is not pointing to that string actually. That string is pointed to by bx. So we just have to copy whatever it is in bx to the x register. Whatever it is in bx to the x register. That's why we write this line here. And if everything is right, then if I execute this program, I should be able to see 509 and 607 on the screen as an output. Let's see whether we get it or not. If we do not get it, then we'll go through the code, we'll try to find out where is the problem, and we'll solve it. Okay, let's see. So TASM, then first we'll be doing this sort of compiling the program, yt program 16.asm. Luckily no error, nothing. So t-link yt program 16. Okay, and then yt program 16. Okay, it is in an infinite loop. Let's see where is the problem. Okay, okay, why is it in infinite loop? Okay, there is this free fall happening, no? Like move this, call this, move this, call this. I want to jump to that is one mistake at least I can see right now. See, after calling this, I just do not want a free fall happen of the execution. So I want directly to come this point. I want the control to go to that terminate program point there directly after calling this function twice. Okay, so let me see if that was the error or something else is also wrong. So I'll just once again I'll do that. So TASM program 16.asm, then t-link ytube program 16 and ytube program 16. Those 509 607. So don't worry, like they are coming on the same line, but as expected, they are giving us the right output 509 607. So let's change this number. And till now, we never said anything about negative numbers. So we'll not try with negative numbers, but we'll try to give the different numbers. So for example, I give there a slightly bigger number, say 3900, sorry. So some number 3098, say, okay, and then 607, let it be like 607, or make it very small, say 6, okay. The first number I made bigger, second number I made smaller, and let's see whether it works or not. Okay, so I recompile, relink, re-execute. So it is showing me the output as 30986098. What is this? 3098 is okay, and then 6 is like okay. Now you know why it is happening. No, do you know why it is happening? It is happening because of this dollar symbol. You see here, when most, that is the justification why it is like that. See, what is happening actually. So first 3098. Now first in our AX, say it was 3098. Initially our string S was like only dollar, 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 and a lots of dollar. So when we converted it to a string, so our string became S is equal to 3098 and some dollars and dollars and dollars like that. Okay. And then when we change it to a smaller number like AX is equal to 6, so we didn't change this string, no? So in that case, what will happen is ultimate string S will be only the first character will be changed to 6, then 098, and then dollar, dollar, dollar. So in that case, the output will be obviously 6098, and that is what I guess happening here right now. 6098. We don't want that thing to happen. So if we do not want that thing to happen, then what we have to do, we have to reset everything to dollar. So that's a small problem. Now, how do we, okay, let me think for a moment and let me come up with a solution. What I think we can do is, instead of relying upon this, you know, this dollar symbol explicitly filling up the end, what we can do is, okay, we can construct this string wherever we're doing this construction, BL plus this loop pop next, no? You just get the character, store it in BX, store it in the, you know, in the string, and at the end, when the loop is over, we can explicitly store a dollar symbol there, and that will fix the problem, no? So what we can do is we can move. So see here, once it is done, SI anyhow will be increased. So we want to this point, that is, we will now explicitly we will store to DL this dollar symbol, and then we'll store this DL character to BX plus SI. Last symbol is dollar. Now this time that problem should not be there, and if we execute it, we'll get the solution, I guess. Okay, now it is 3098 and 6. Okay, that's done then. Now you might be thinking, can we display it on two different lines? You can do, you know, displaying the number, and always after displaying the number, it's a next line. You can assume that, okay, after displaying the number, always it is a next line. If you want, you can do that way, or displaying, you know, task, or what you can think it of is like, okay, the task of this particular function is only to display the number. If you want a new line, you can explicitly display the new line whenever you want. I think that is much better, I guess, you know. And say, for example, we want to display the new line character explicitly, so call display number, and then we can write like move AH, comma. So first thing is that we have to move DL because we want what character we want to display, and then move AH, comma 0 to H, and then int 21H. Now see, this is the code to display a new line character. So what we can do is we can write another procedure here. So it's a now display or new line, or now print new line. Say print new line, or simply call new line. So new line, this is a procedure, and we want return here. We want new line and procedure. Okay, and this is our basic skeleton. But here what we want to do, whenever we call it, we know that like we have to store 10 to DL, we have to store 2 to AH, and then we have to call in 21H, and then we'll be calling this new line procedure whenever we want to display a new line. Say for example here, call new line procedure, and then display this, then call new line procedure. Okay, so that way I think it will display the new line at the end of each number, because we are displaying them explicitly. It's not part of the display number procedure, it's a different procedure. Whenever we want to display them in a new line, so we will call them explicitly. So let's see. So 3098 and 6. The third new line is coming because we are calling here this new line here explicitly. Got it? The blank line is coming for that reason. Hope people have understood this program, and as I promised, now what I'll be doing is I'll be showing you, I'll be scrolling down the code slowly, so once again of your own, and you can check your understanding. Okay, so this is the basic skeleton, the code segment. Here the comment is written everywhere, it is the same. This is the number that we want to display, then we are calling display this and a procedure, calling new line procedure to display new line. Then we are storing 6 in AX. Again, we are calling this function to display the number 6 on the screen, calling new line to display a new line. And then once everything is done, terminate program. That is the end of the program, sort of. This label, that is, go to the code whose label is this, or which is labeled by this particular name. Then we wrote the code for display procedure. It assumes the number is in AX. So we are first, we use the CX as a counter. So clearing CX first, then next div, this repeated division thing. So first before division, we clear DX, because division is always like DX colon AX. DX AX pair 32-bit combinedly, it is divided by a 16-bit number. And what is that 16-bit number by which you want to divide? You want to divide it by 10. So this is the thing, div DX. Then we know quotient will go to AX, remainder will go to DX. We want to push the ASCII code, so we are adding 0. Then we are pushing whatever it is DX to the stack. And then we are increasing how many times you are pushing it. To keep track of that, CX is increased every time. And then whether we want to repeat the process, whether we want to go back to next div or not, that is decided basically by the quotient. That is, if the quotient is not yet 0, we'll be comparing it with 0. If it is equal to 0, then it is done. If it is not equal to 0, we'll go to next div and we'll repeat the process. Now, if it is equal to 0, now it's done. The stack is ready. Now we just have to pop the content of the stack and we have to construct the string. So what string, where we want to store the string? We want to store the string in this variable str1. str1 is nothing but it is just a like an array of characters, that's all. Okay, so here we are str1, and then we are clearing si because we want to use it as an index, and then pop next. So basically what we do, we pop, we store the lower order 8-bit to bx of si, we increase si to point to the next character, and then we repeat this process as long as the stack is not empty, or it's not stack is not empty, as long as specified by this counter CX. See here we are using this loop instruction. So default is CX, means this loop will be executed as many times as the value of CX. And you see here, every time we push to increase CX, so it means we know basically how many times we have to perform the pop operation. Done. Once it is done, we moved DL dollar symbol to DL and move it is sort of like whenever you are constructing a string in C programming, you put the null character at the end. That's what I'm doing here actually. At the end, in the last index, I'm storing this dollar symbol just to mark the end of the string. Done. Our string is ready. Next task is only to display the string. You just store we know, when we do how to display a string, by storing 9h in AH and then calling int21 interrupt service routine. But the thing is, that time it assumes that the string is actually pointed by the X register. So for that reason, right now we know the string is pointed by BX. So BX we are storing in DX, and then this is the standard way of displaying a string which is pointed by DX. So we did it that way. And this is the end of the procedure, like return, like from here the control will go back to the place from where it was called. And this is to indicate that that is the end of that particular procedure. Done. And once this procedure is over, the control will see, suppose we have called it from here, the control will reach to this point. So anyhow, okay, up to this point we have understood. Then the next thing is this new line procedure, because every time we want to display new line, we want to do it through this particular procedure. So for that reason, we know new line means we want to display the character whose ASCII code is 10. So for that reason, 10 is stored in DL, and then why only in DL? Why not in some other register? Because that is the default. That is the default 8-bit register, 8-bit register to store the character you want to display. Okay, so if you store anything in DL, and after that if you call these two instruction, that is first you store 2 in AH and then call interrupt service routine 21H, then it will display the character which is there in DL register on the screen, that we know, I guess. And then this is the end of the procedure, done. And then see here, this is the level that I talked to you at the beginning, like jump terminate program, that is after displaying 6 and then the new line character, from here we just do not want a free fall to happen and execute this code once again, unless I know that is quite illogical. So if we want to prevent that free fall, then what we have to do is, okay, from here we want to go to the end of the program, and that's what this terminate program level is doing. Okay, this is the end of the program, that is store 4ch in AH and call interrupt service routine, and that's all. That's the end of the program. Okay guys, then hope you people have understood this program. Now suppose we want to display negative numbers. Say for example, instead of this number being 3098 or 6, they are say for example minus 3098 or minus 6. In that case, how to do that? So, and that will be the content of the next video. So in the next video we are going to learn like how to change these. We're not going to rewrite everything from scratch in the next video. We are going to change this display number procedure itself to take care of the the negative numbers. Means it will work for both positive numbers as well as negative numbers. We'll see how to deal with the positive numbers. We already have seen it, we already have done it. The negative number parts, we'll be seeing it in the next part of the video. Okay guys, then that much only in this part of the video. See you with the negative numbers in the next part of the video. Till then, have a nice day.